All right, so the bulk of the unit is actually going to be over domain and range. Domain and range is something that's slightly complicated, used to be slightly complicated for students to understand, but I think throughout the years I've kind of figured out a good way to teach it for students to remember how to write it correctly every time. Okay. Anyway, so introduction to domain and range, that's going to be page 26 in your notebook, in your binder. Okay. So domain is a set of all possible input values for a function. What we're talking about with domain and range is what are the boundaries of that graph, of that function? Like what are all the possible set of x values? What are all the possible set of y values? And you want to be able to list them. Now, sometimes you have so many values that you cannot list them all. So there is a way to write those. Sometimes you have very specific values, and those are the ones that are a bit easier to list. So we're actually going to start off with the easy part, okay? Domain is a set of all possible input values for a function. It represents the independent or the x values. Domain is listed as a discrete set of values or it can be listed as an inequality from least to greatest. Same thing with the range, except range represents your y values. Okay. Now, a lot of students always gets mixed up. The hard part about domain and range is students get mixed up on which one goes with which one goes with x, which one goes with y. So for domain, think about this. It's alphabetical order. D goes before R, just as X comes before Y. Alphabetical order. D comes before R, just as X comes before Y. So domain is your X values, range describes your Y values. It says fill in the domain and range for the vending machine function. Okay. What are all of the possible inputs? What are all of the possible codes that you can put into this vending machine? Well, I can type in A1, A2, A3, A4. I can type in B1, B2, B3, and B4. What are all the possible outcomes? What are all of the products that I can receive from putting in these inputs? That would be M&Ms, trail mix. And the thing about domain and range is that you have to list every one, not just some of them. Chips, pretzels, Skittles, Snickers, Twix, and Reese's. Okay. So we want to do all of these are considered what we call discrete functions. And the reason we call them discrete is because there is a certain number of numbers that you can list. There is your list are going to be a certain amount of digits. Okay, these are all discrete functions. So when they are discrete, list the values. Okay. So for domain, don't remember domain is X, range is Y. And when you list them, you want to make sure you're listing them in order from least to greatest. Okay, so smallest to large. My X values are anywhere from -2, 0, 3, 6, 8. And also another rule, you want to skip over anything, any numbers or any values that do repeat. Okay, we will have an example of that. And for the range, this one's listed from greatest to least, so I have to make sure, double check, -9, -8, -4, 0, 6. Don't get too excited. This is not the complicated part of domain and range. Number 2, domain. What are all my x values? What are my y values? My x values, in order from least to greatest, -5, -2, 0, then 3. My y values, -12. Should probably do a different color. -12, then go to 0, 8, 20. Number 3, this is a map. This one is not, we're not asking if it's a function or not, so you really don't have to draw your t-chart, your table for this. Okay, so you're just listing these values in order from smallest to largest. -4, -2, 3, 7. Okay, for your y values, notice that -8 repeats, but once again, any repeating values, you just list them one time. Okay. Number 4, Susie's having a birthday party at Jumping Zone. It costs $11 for each kid to jump. Her mom says she can invite a maximum of 4 kids. Make a table to show the cost of inviting 1 to 4 friends, then find the domain and range. Well, if she invites 1 kid, that'd be $11. If she invites 2, 22, 33, and 44. So domain, how many kids can she invite? She can invite 1, 2, 3, or 4 kids. The range, what is the cost going to be? It can be 11, it can be 22, it can be 33, or it can be 44. Okay. Flip the page. The complicated part about domain and range is going to be your continuous values. When domain and range of a function includes a continuous interval, meaning your points are all connected, then it will be written as an inequality. Describe in words the values on the number line below, then write an inequality to represent the values. Okay, so remember closed circle, we're including the number 18 and older, not included kids less than 3 years old. Okay, just going back over that part. So if we're talking about the description of this number line specifically, we would say, description. Oh yeah, there's only, so you would say that X is, you want the numbers to be -4 or what? Higher, right? Is greater than or equal to, why equal to? Because it's filled in. -4. But you want the numbers to be what? Lower than 3. And since that's an open circle, you don't want it to say 3 and under. It just says less than 3. So I'm going to write n less than 3. Now, how would you write this in an inequality form? Well, you would say -4 is going to be the smallest number, less than equal to x, less than, not equal to, less than 3. The one thing about domain and range, you're always going to either use less than or less than equal to every time. Less than or less than or equal to. That is always going to be your starting point. Okay, so domain and range from graphs. Domain is going to be how far, what your boundaries are from the smallest x to the largest x. That's your domain. Your range is going to be the boundaries from your smallest y value to your highest y value. That is your range. Okay. Now, whenever, and this is the format that I want you to use every single time when we're talking about domain and range, when we're writing domain and range, anything like that, you want to find the domain from the left to the right, range from the bottom to the top, always minimum to maximum, small number to large number, minimum to maximum, okay? So for the domain, you are going to fill it in with, really? You're going to fill in the middle with an X. For range, you're going to fill in the middle with a Y, okay? And you'll fill in the numbers here as we go. I'll show you how to do that with these examples right here. So number 5, domain. Starting with the domain. Yeah, okay. The easiest way to do domain and range is to, especially with linear, is to label your endpoints. That's going to make it so much easier on yourself, is to label the endpoints. So that point is 2, 0. Make sure you label your X and Y. And the other point is -1, 2. X and Y. That way, now whenever you're writing the domain, something is less than X, less than something, right? A number is less than X, less than another number. You know you have to write those numbers in order from min to max. Okay. And because you labeled those points, now you know exactly what numbers to fill it in. Which one's your minimum between -1 and 2? -1. -1 has a open circle, so you do not underline the inequality. 2 is the maximum number, so you put a 2. Also an open circle, so you don't underline. That is your domain. Those are your boundaries. This line goes from -1 to 2. Let's try with the range. Something is less than the Y, less than something. Minimum to max, same thing. But since we are talking about the Y values, we're going to focus on these two numbers. Okay, so between 2 and 0, which one's the smallest one? 0, open circle, leave it alone. Highest number, 2, open circle. Once again, leave that alone. There is your domain and your range. That is your answer. Let's try the next one. Oh my goodness. All right. Label your endpoints, 4, 6. This one is -4. Okay. So for the domain, number is less than X, less than a number. But what happens with this one? Oh, something. We have -4, but at that -4, we have a closed circle. So this time I am going to underline. And at the +4, we also have a closed circle. So once again, underline. My minimum number, my maximum number. Okay, let's do the range. Something special happens with the range. Okay, with the range, we're looking at the Y values. What do you notice about those Y values? They're both exactly the same. So when you have the same number on both ends, you would write it as Y is equal to 6, meaning it's never going to deviate from the 6. It's always going to stay a 6. 6 is the only possible value for that line. Number 7. I'm going to write it over here. -5, 10. Yeah. And this one is 15, 20. So for the domain, I'm just going to do this. I'm going to leave the blanks out. Okay. What's my smallest X value? The -5. -5 is at an open circle, so I'll leave it alone. The highest is 15. 15 is at a closed circle, so we underline it. Okay. Where most students are going to mess up is they're going to forget to double check those inequalities. They're going to forget to check those open and closed circles. Okay. Next. What is the smallest y value? A 10. 10 is at an open circle, so leave that. And then 20. 20 is at a closed circle, so we underline it. Now, this is also a graph, but notice how the points are not connected. That would make this one a discrete function, okay? Remember, a discrete function is where you have a certain list, okay? Will the domain and range of this function be written as an inequality? No. Domain and range will be a set of values. A certain set of values. Why is it a certain set of values? Because the function is discrete. I can't spell discrete. The points are not connected. It's not continuous. If the points are connected, it's continuous. You use inequalities. If they're not connected, it's discrete. You use the set. Okay. Now, what would make this a lot easier, and you know where I'm going with this, is to make a table. And my table, -5, -1, -2, -3, 0, 0, 2, -2, 4, -5. Okay, so find the domain and range of this function. Well, the domain, since it is discrete, I just write the numbers, list numbers in order from least to greatest. -5, -2, 0, 2, 4. The range, list the numbers in order from least to greatest. And those are out of order. So let's try to do this right. -5, -3, -2, -1, 0 being the highest. Okay, so you go ahead and get some practice. The next day, you're also going to practice a little bit more, just because this takes a little bit to get used to. Take some time to get the hang of it.